So we're going to be looking at finding the length of a line segment. So if I draw a line segment, let's say AB, okay, if I give you the coordinates of A, let's call this x1, y1, and I give you the coordinates, coordinates of B, all you need to do, you're finding the distance. This is the distance formula. You're finding the distance from here to here. I want to know how long this line segment is, okay? This is a formula you use. So I give you two coordinates. These are two coordinates of a line. I want you to find the distance, so the length of this line. Does it matter which one I call x1 and y1? No, so let's call this x1, y1, x2, y2. All you need to do is now plug this into the formula. The distance, or the length of this line segment, is equal to the square root of, what's x2? Always label your coordinates so you don't get confused. What's x2? 3 minus, what's x1? -4. Make sure you are careful with your signs. Squared plus, what's y2? 1 take away 7 squared. Follow BEDMAS. We have to solve what's in our brackets first. What's 3 take away -4? 7. 7 squared plus, what's 1 take away 7? -6 squared. What's 7 squared? 49. Plus, what's -6 squared? +36. Okay, I'm just gonna, I have room. 49 plus 36. 85. Square root of 85, we'll round it to one decimal place, is approximately equal to 9.2. Therefore, the distance, if we were to graph this from P to Q, is 9.2 units. They didn't give us a unit here. In this question, you're given a coordinate, A, and you're given an equation of a line, okay? They're asking you to find the shortest distance from point A to the line. So basically the distance from point A and the line, but the shortest distance. So what you need to remember here, what's important is that the shortest distance, I guess it's common sense, is a perpendicular line that goes through it. If you think about it, if I draw a line from here to here, that's a pretty far distance, right? From A to that yellow dot. The shortest distance would be a line drawn through it that's perpendicular. So from, let's call this, so from A, we have to figure out where this point is. I need to know a point that is perpendicular to the blue line, because they're asking us to find the distance. So eventually we need to find the distance from A to B. Okay, so, well, right now, because we only know point A, we have to figure out point B somehow. Once I know point B, I can calculate the distance, right? The length of the line. But we're working with an equation of a line. Because line B is perpendicular, I'm drawing a line that's perpendicular, we want to know what is the equation of my pink line. If I can figure out the equation of the pink line and I know the equation of the blue line, we can use that information to figure out where they intersect. They will intersect at that point, which is point B. Point B is actually a point of intersection of the two lines, right? I can draw a line all the way through here, right? I can draw this line, and I know that this point B, which touches the line, is a point that intersects it. Well, so far in this equation of the pink line, we know x and y, right? We have a coordinate on the pink line, and we know the slope of the blue line. If the pink line intersects it at a 90-degree angle, what would the slope of the pink line be? The slope of the blue line is 2/1. They're perpendicular, so what's the slope of the pink line? -1/2. You mean negative reciprocal, right? So let's plug that all in and find b. So x and y was 6 and 5, and the slope we know has to be negative 1 over 2. So that's going to be multiplied by 6 over 1, and we're going to solve to find b. 5 equals negative 6 divided by 2, which is negative 3. So what's b equal to? 8. Good. So the equation of the pink line is y equals what? We know the slope had to be negative reciprocal, negative 1 over 2x. What's the y-intercept? Plus 8. Yeah. Now we know that this pink line has an equation of negative 1 over 2x plus 8. We have the equation of the pink line. We have the equation of the blue line. We need to know at what point do these two lines intersect. So we will solve this by substitution. Well, y is already isolated, right? Y is equal to 2x plus 3. So let's replace that for this equation. Instead of writing y, I'm going to write 2x plus 3 equals negative 1 over 2x plus 8. Right? I just replaced y with the value of y from the other equation. We're replacing it. We're substituting it in. So we can make this a fraction to make it easier. 2 over 1x. Negative 1 over 2 becomes positive 1 over 2x. And positive 3 becomes negative 3. Okay, when we isolate, x is equal to 2. Well, I'm trying to find the point of intersection. I just found the x value of the coordinate. Now what do we have to find? The y value. Okay, so we'll plug in this value of x into equation 1, since it's probably easier to work with. Y equals 2x plus 3. We want to know what y is equal to if x is 2, right? Yep. Y equals 4 plus 3. What does y equal? So therefore, the point of intersection is located where? 2, 7. That was what part of the line? Does anyone remember what I labeled that as? B. Exactly. Okay, so that was B. So B is located at 2, 7. We know where A is located. The question was asking to find the distance, the shortest distance from this point to the line. Now you need to find the length, the distance from A to B. So now to answer the question, plug in the values into your distance formula. x2 minus x1, so I'm going to work backwards. 2 minus 6 squared plus 7 minus 5 squared. Okay, now you have to be careful when you're writing this. If I'm calling this x2, so I'm doing 2 take away 6, I have to do 7 take away 5. It's got to be x2 take away x1 and y2 take away y1. Negative 4 squared plus 7 take away 5. 2 squared. 16 plus 4. And the square root of 20. We'll round it off to 4.5. So therefore, the distance from A to that line is approximately 4.5 units.
Made with Doodlecast Pro.